In this tutorial, we are going to learn how we can control the embedded LED on the Arduino UNO R3 using LabVIEW Community Edition. So what we have here is the Arduino UNO R3 that is connected directly through a USB cable to our PC. And this Arduino has an embedded LED on its board that is directly connected to digital pin 13. So by controlling the state of digital pin 13, we can control the LED. In other words, we can turn on and off the embedded LED based on the state of digital pin 13. If we have a high state, the LED will turn on. If we have a low state, the LED will turn off, and we can change the state of the pin directly from LabVIEW. So the first thing we are going to do, we are going to open LabVIEW Community Edition and then go to Tools, Hobbyist, and directly to the Firmware Wizard. So what we need to do here is to upload the firmware in order to have a successful communication between LabVIEW and Arduino. So for the device family, we choose Arduino. For the device type, we have the Arduino UNO. And for the communication protocol, we're connecting our Arduino through a USB cable. We're going to press Next. Then here we are going to choose the COM port or the USB port that our Arduino is connected to. You can retrieve this COM port from Device Manager under COM ports to know exactly which COM port your Arduino UNO is connected to. So for our case here, it's COM4. Then we're gonna press Next, Next, and once the firmware starts uploading, you will see the LEDs of the Arduino UNO flashing, which means you had a successful upload. So let's press here Finish, go back to LabVIEW, and create a new VI. So here I already have an empty VI, so I'm going to open it, or you can create yourself a new VI. So as you can see, we have the front panel in front of us and the block diagram. So let's put these side by side. So this is our front panel, and this is our block diagram. Now what we are going to do is we are going to go to the block diagram directly and start coding. So in the block diagram, in the functions palette, what we have here is the hobbyist library. And inside this hobbyist library, we have all the blocks or required blocks for us to be able to communicate with the Arduino UNO. So today we are going to use the digital write block right here, or the digital uh, write block, in order to send commands to our Arduino UNO, and specifically we want to control digital pin 13. Now the first thing we want to do whenever we work with the Arduino UNO with LabVIEW is to insert the open block and the close block. The open block is used to establish the communication with the Arduino UNO, and the close block is used to close the communication once we abort or stop our LabVIEW code. So these are essential codes that must be always there whenever we're using an Arduino UNO. The third block that we are going to use is the digital write block. So let's put these there, align them, and perhaps distribute them horizontally. Next, what we are going to do, we are going to place our digital block inside a while loop. And then we are going to connect our open block to our digital block through the data communication line and the error line. So this is the pink line here is the data communication line, and the green one is the error line. So this error line is essential because in case we have any error, we need to do or perform a certain task. In this scenario here, we will see that we will stop our code whenever we have an error. Now for the open block, we need to specify the COM port that our Arduino UNO is connected to. So in this case, we know that it is COM4. So there you go. Now for our digital block, we have two inputs. We have to specify the digital output channel and to specify the value that needs to be sent. And this value is a Boolean value. So if we send true, it means we're setting pin 13 to high, and accordingly we are turning on our LED. If we send false, it means we're setting pin 13 to digital low, and accordingly we are turning off our LED. So for the digital output channel, we can create a constant and type in 13 because we know that the embedded LED is connected to pin 13. And for our controller, we can choose a Boolean push button and call it LED button. And we can wire it as the input to the value or output value that we need to send to our, of course, digital pin 13. And there you have it. Now, one more thing, we need to create a stop button in order to stop our while loop. But what about if we have an error? If we want to stop the code whenever an error occurs. To do that, what we need to do is to go to cluster, choose the unbundle, and then for this one, I can get the status. And this status will be true if there's an error, and then I can feed it to my stop condition there to stop my loop, and it will be false whenever we have no errors or there are no errors in the code. So it's pretty useful. Now I need also to stop my code through the stop button. So what I'm going to do right here, create a stop button, hide its label, US icon. And now we can stop our while loop, or the while loop will stop either directly by clicking the stop button or whenever we have an error. So for that, we need the Boolean or an OR gate in order to have these two inputs. So if one of these inputs is true, the code will be stopped. And there you have it. That's it for our code. It's as simple as that. Now, one more thing, we can have a virtual LED that can show us the status of our physical LED at the same time. So we can have both physical and virtual LED. So for that, I will call it LED, and I will wire the output of the LED button as an input to my LED or virtual LED indicator right there. Now, all what we need to do is to see the Arduino Uno in front of us, and let's run our code and see what will happen. So, as soon as I turn on my LED button, right, let's minimize this one and maximize here our Arduino Uno. So, if I turn on the LED on my virtual interface, the physical LED turns on. If I release the button, the LED turns off. I press it, the virtual and physical LED both turn on, and we can see them turning on and off together depending on whether I press or release the LED button controller. And that's it for this tutorial.